Good afternoon, everyone. I am Wu Kai Li, an engineer in Zhihai Semiconductor. Today, I will share you the detailed operation instructions of APM32F4 OTP. The contents of this lesson is divided into three sections. The first section is OTP Overview, including a brief introduction of OTP. The second section is OTP Functions and its applications scenarios. And the third section is the programming introduction of OTP area. Firstly, OTP Overview. OTP, One-Time Programmable bytes, which means that we can only implement the one-time programming in this area. Unlike our flash, which can be programmed multiple times. As to APM32F4 product, there are a total of 16 data blocks and a lock block in this OTP area. Each data block is 32 bytes, totaling 512 bytes. Its address area ranges from 0 × 1 FFF7800 to 0 × 1 FFF79FF of our APM32F4, which is described in detail in the data manual of APM32F4. You can refer to the user's manual. Secondly, OTP Functions. OTP can only be programmed once. This area is also independent of flash area, so it can be better applied in some scenarios, such as the calibration values of some devices. For example, some gas sensors or input devices are highly sensitive to external environment. So we can provide a standard environment for our products when the production line is started. A corresponding calibration value is written into the OTP area, and then the product is shipped and used in the application scenario. In the program, the calibration value of the OTP area is constantly read to make our product more stable. In addition, it is about the preservation of the serial number. For example, there is a barcode on the product we buy, which is a unique identifier of the product. And similarly, some products that we produce shall be also provided with serial numbers which can represent different meanings. For example, the serial number of a product is in the format of A, B, B, C, C, D, 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 wherein A represents some characteristics of the product. For example, if the product has rewriting function, then A is expressed by 1. If the product has hardware anti-rewriting function, then A is expressed by 2 and so on. B represents year, for example, 00 to 99 represents the year from 2000 to 2099. C represents production batch, for example, there are 01 to 99 batch numbers for our products produced in this year. Then the following DDD represents the production sequence number of the production batch. There may be many types of products. For example, the cipher with the serial number of 20001000001 represents that this product has hardware anti-rewriting function, and that it is the first electronic payment cipher in the first batch of products produced in 2000. Besides, our product is encrypted. That is, reading the UID of our chip's APM32 generates an information string through an encryption algorithm. And then this information string is saved in the OTP area. And then every time it starts up, it will decrypt and compare the information string in the OTP area. If the information string is consistent, it will run the main program. If the information string is inconsistent, it will exit the program. For the same chip, for example, if the software of chip A is stolen by someone else, and then it burns into chip B, because the UID of the two chips are different, then the generated information strings are saved to the OTP area. If the saved data is about A OTP, then all the programs are copied to chip B completely. In this case, it won't work because its information string doesn't match the UID of chip B. Therefore, the OTP can also be used in the product encryption. Then, let's review one more feature of OTP. OTP area is one-time programmed and cannot be changed after programming. Therefore, In the upgrading process of our product, we do not need to consider that this area may be revised due to the failure of our product upgrade or other reasons. Besides, the programming unit of the OTP area is very small. For example, the smallest programming unit of Flash is usually page. Namely, about 1K. Different products have different smallest programming units, including 1K, 2K, or even 128 KB. As mentioned above, an OTP area is 32 bytes and its size is very small, and this OTP area does not occupy our main storage area. You can see the structure diagram of this memory. The OTP area is separated from the main flash and will not occupy the memory of main flash, nor cause a waste of the main flash. There are many application scenarios of OTP, so how to make use of it? Thirdly, I will introduce you OTP programming. The OTP area can be self-programmed. Self-programming is the same as that of the ordinary flash. Step 1, unlock flash. Step 2, program flash. And step 3, lock flash, and its code is the same. For example, call FMC unlock to unlock OTP area. Then implementing programming of OTP area and writing the address. Then data and programming. Here, I design a program that the data in this area is programmed not in the default state, so that the system will not repeat the programming of the OTP area after repeated power on. Then after the programming, we will read out the data and we can see that a piece of code can be successfully programmed through the serial assistant. And then we can also view the data that we programmed into it in the context of our Keel simulation. This is self-programming. In addition, it can be downloaded in way of ISP. After boot 0 pin of the chip is connected to high level, and then boot 1 pin is connected to low level. Then the chip will enter ISP mode. At this point, it can access our F4 series chips with a USB cable. This USB accesses to the areas of P11 and PM12. We can use our official host computer, DFU programmer, to search and connect the device, read the chip, and read the address of the OTP area. At the moment, the OTP area can be displayed in the host computer. Then, we can write the desired OTP data into a bin file. And the bin file can be downloaded into our chip. Step 6, because the previous program has already coded in. That is, I have written the data into one FFF7800 area. Now I move back by 4 bytes and edit from 04, and click Start button to write the programming starting address. Then click Start button to update the firmware. At the moment, we can check whether our programming is successful through the software message prompt. If successful, we can read the OTP area. For example, here I read the OTP area and the programming is successful. These are all the content of ISP programming. In the end, the programming can be implemented through emulation download. We usually take Keel for our development object. During the development of Keel, the corresponding OTP.s file provided an SBK, and then sent to our users to program the OTP area. First of all, add the OTP.s file into the project, and then edit the OTP.s file. Because it is self-programmed, and downloaded by ISP, here I'm going to add the third one. Namely, move back by 4 bytes to put the third one in here. For example, I write the data of 003500 for 9 into it. Add an OTP download algorithm into the project after modifying S file in that pattern bar. Configure the download algorithm, and then add the OTP download algorithm. After adding it, we edit the project and download it. At the moment, you can view that the OTP area has been changed on the simulation interface. These are all the content of the programming by simulation download. The OTP area can be used in a variety of scenarios and programmed differently. These are all the content of APM32F4 OTP application and programming. Thank you.